main video series, I used a muscle mesh that didn't have any self-intersections or muscle-to-muscle intersections or muscle-to-bone intersections, and I showed this little network that you can use to check for them. But you see, in this case, my original muscles actually had quite a bit of intersections, and I'm going to show you in this video what I did to fix them. So I started off by looking at the self-intersections. So I mentioned in the initial geometry setup video that self-intersections aren't as critical as other ones because the muscle solidify is very good at fixing them. However, it does change the shape. So if we look at this one, I've faked a little problematic area here. The muscle solidify can resolve that, but it just gets rid of it. So it changes the shape of it. So depending on your situation, you might not want that. So that's something to keep in mind. Another thing is if you decide you want to separate your remesh from your muscle solidify, so you turn off the remesh on your muscle solidify and have a remesh beforehand instead, then it's very important to notice that it's not going to fix those self-intersections and it's going to cause some funny looking tets. So do make sure to fix any self-intersections if you're using this method. Now, let me show you what I did to fix these self-intersections, just as a little demo. I'm not going to do the whole thing. It is a bit of a slow process, especially because I'm not a modeler, so I'm not very efficient at it. But there's this topo build node. And if you connect the same mesh into both inputs, if we use the second mesh as a projection surface, so you can use it to slide along that surface. So I will template this incoming mesh so that we can keep an eye on what the surface is. And now what I did was basically, well, firstly, let me just show the different settings. So shift 1 is build. All of these over here correspond to different numbers. So the ones I like to use are shift 4 at brush, shift 5 for the smooth brush, and shift 1 for build. So I'll be in build now. I'm going to turn on display points, find that a bit easier. And what I'm going to do is I'm just going to try and get a nice flow going on here. I don't want to spend too long on this, but you can see it's keeping it on the surface. I select an edge to see where the next point is, and I'm just going to bring it back here. Same with this. Looks like that is the next one. If you want to disable the projection, you can hold down I while you move it. So now I can just get it off that surface a bit. And if you work your way around like this, something weird happened there, but you can eventually, I also used the smoothing, and I smoothed this down quite a bit, and I got it to look something like this. And then what I did after that was I used another topo build, this time with this new mesh as the projection target surface, and I just used that to just get my loops a little bit neater. And it was just convenient to do it in a separate node so that it had the new projection mesh instead of this ugly one. And then that fixed that issue. So I highly recommend using the topo build to do some fixes if you run into this kind of issue. Even if you're not much of a modeler, you should be able to figure it out if I could. So let's look at the self-intersections that I did actually have in this model. It turned out to not be a proper self-intersection per se, but rather that there were these strange floating duplicate points on both sides of this mesh. So I actually ended up deleting them. And you can see over there, that fixed some of the issues, but then I put down a polydoctor, which is a node that I highly recommend, especially for identifying issues. It doesn't always manage to resolve them, but if you use them in mark mode, you can use it to find some dodgy polygons. Sometimes it manages to fix it. In this case, it did. So That's very useful. I don't even know what exactly was wrong, but it fixed it. Before I did this, there's this Vellum sim that I did on here, and it was just causing weird behavior and explosion of these points because I didn't remesh it. So now let's actually look at this Vellum sim. So basically, my thinking behind this was, let's scale the muscles down and then inflate them up into their target positions. But if they start off without any intersections, then as you slowly scale them up, they will hopefully be able to resolve their collisions if you do it in a Vellum solver. So I created a Vellum solver with the gravity off, because this isn't a sim. We don't want any forces or anything like that. Just want it for the sake of collision. So I turned off gravity, I reduced the time scale. I'm not looking for any type of physical accuracy, it's just for collisions. So how did I scale these muscles down? Basically, there's this useful node called extract centroid, which I ran over the muscle ID attribute. I also told it to transfer the muscle ID attribute to the output points. So now for each muscle, there is a point corresponding to its center of mass. And then I use this node transform pieces, which takes these incoming muscles. The second input here is going to be the points where we're going to alter their P scale. And then the third input is going to be their original centroids. So now you can see that if I slide this, it scales the muscles around their individual centroids. So I tried a similar thing for the bones, and it didn't work because, especially because of the spine, I was having issues with the spine that whereas it scaled up, it was just colliding into muscles weirdly. So what I found worked better for this was I delta mushed it to quite a thin state. And then I had a blend shape that keys it from this state into the original position over the first 25 frames. And I also open up the channel. I changed this curve so that there's a really quick ramp up from this to the target one, but then takes a while, then slows down as it reaches the final point. That was just to quickly for the bones to get ahead of the muscles in a sense. So I'll just show, if you look here, this is sort of what it looks like, what the curve looks like by default, and then you can just select the key, change the tangent to get that sort of behavior. So that worked quite nicely. So now if you play this, you see it expands. And now let's look at how I got the muscles to get from this into their actual final position. So the way I thought of it is you have these muscles and you have this target shape, and I want a connection between each of these points and its corresponding point on the target shape. I want to attach those together, and the attachment constraint will hopefully pull it towards its target. Now, the easiest way to create those attachment constraints was to, instead of doing it between this muscle and this muscle, is actually to just duplicate the muscles. So take the original muscles and then attach them to themselves, right? And to attach them to themselves with this attached to geometry type, when you use attached to geometry, you're attaching to geometry that's coming into this third stream. So the third stream is typically used for collisions, but it can also be for geometry that you want to use to influence your sim in some other way. So I've merged together both my bone geometry, which I use for collisions, as well as this target position for the muscles. Merge them together and put them in here. And now here I specify I want the target muscles group, which is this one. And if you pay attention, you'll see that I've used this expression to disable the collisions for the target muscles. So even though they're in the collision stream, so to speak, they're not acting as colliders. I've disabled their collisions because I want the muscles to be able to pass through them if it's in the way. I don't want them to act as gliders. I want the actual bones and the main muscles to act as gliders, but I don't want them to get, I don't want the target ones to get in the way. So I've disabled those collisions. I've attached them when they're in this sort of original state. But after I've created those attachment constraints, so you can see here, each point has an attachment constraint to itself, essentially. But by itself, I mean each point in this stream has an attachment constraint to each point in this stream. I now take this simmed stream and I'm going to blend them into the position that I want. Not over time, I just do that between this step and this. And now I'm ready to create the cloth settings for what I'm going to sim. Quite stretchy. Then I used the Vellum pressure because I thought, oh, I want to inflate it like a balloon. I don't think this actually makes much of a difference in the end. So you can experiment and see if this does anything. It probably doesn't. But then here, let's run the solver. So what I like to do is attach my intersection checker to the solver as it runs and play it through and see what happens. Now, for the sake of speed for this video, I've pre-cached it. So let's look and see what result I got. Okay, you can see some intersections have appeared. Sometimes they'll go away after a while. Sometimes they won't. It looks like in this case, these ones aren't really disappearing. Something's happening there. And if I have a look, oh no, all of these muscles, which are actually meant to be underneath this trapezius, is now sitting on top of it. Okay, so, and if we look over here in this problem area, I'm going to switch to display as points. Here's a little tip. If you go to this node and you go to the geometry spreadsheet, you can see I specify which muscles are the problem muscles. So in this case, I think it's this infraspinatus and triceps brachii that's causing the issue. I'm even going to copy this. I'm going to create a visibility node. And I'm going to say at muscle ID equals paste. I just want to make sure that there's no gaps. And I want to say non-selected primitives. Let's see what that did. Yeah, now it's showing the ones I'm interested in. So basically what's happening is these muscles are sort of colliding in a ugly way, which we don't want. If we look at the actual original muscles, which I have here, just duplicate this, this muscle's sitting nicely on top of the other one. Well, it's got some intersections, but that's the position it's meant to be. And here we have this ugly crashing. Okay, so what I'm going to do to fix that is I'm just going to scale in the starting position. I just want to scale this purple muscle up a little bit so that it starts in a better position for this other muscle to slip in under it. So to do that, I've basically duplicated one of this node. I specified the muscle in question, which is that one. In this case, it is going for a point, so you'll have to know what name you're looking for. So just be aware of that. But you can specify the one you want, and you can change its scale. So you can see reading in the cache. I want to read from here. So if I alter this, it is scaling it up. So let me just go back to whatever I had before. Okay. And then the other thing I'm going to do is to move this trapezius out so that it's on top of all these other muscles. And I just did that with an exploded view node where I specified the trapezius and I sort of scaled it more on one axis. But you can also just use a transform node with whichever muscles you want. I can't remember why I decided to use the exploded view, maybe because I was doing multiple muscles at some point and wanted them to move in different directions. But do whatever works for you. It doesn't matter too much. You just need to move muscles out of the way if you need to. So now I've got those set. This is at some point when the muscles on the abdomen were exploding, I tried scaling these up a lot and it didn't work. So I just left those bypassed. And also I had to change the collision radius at some point, but it ended up being unnecessary. So now with that, I'm going to look at my preloaded cache for this. I'll turn off the visibility again. Now if we play this back, turn this off. Okay, yes, I was going to say, I'm sure there are some things that pop up now and then. So they do pop up here and there, and then they generally tend to resolve themselves. I let it run till about frame 50. So from frame 25, it's in the more or less the correct position, at least in terms of the bones, but then give it about that amount of time to settle again. And there we go. So now, in my case, I cached this out as a frame range so that I could show it for the video. But if you just ran it live and there was a frame you liked, you can just have this. You don't need to even have it as a time-dependent cache. You could just cache out a single frame if you want. But instead, in my case, I'm just going to stash the input on the frame that I liked. So now when I scrub the timeline, it's not going to change. I just want it to be stuck on that one. There was just this one little problem area remaining. I'm going to switch it to the. So in this case, this is the reason I have the switch. When you're running the sim from the beginning, we want the inflating bones to be used. But if we've cached it out to on a specific frame and we're now on any old frame, we want to compare it to the rest bones. So that's just what I have there. And now they're just those two little bits, and this is just going to isolate those muscles that I found using the geometry spreadsheet, same way I showed before. But if you look in here, there's basically no intersection. They're just touching. So that's really not going to be an issue, especially once it gets remeshed. That type of issue is going to go away. Okay, see now? It's gone. So don't get too hung up on that kind of thing. So now we have fixed our intersections, but we've only done the one side and they're these central muscles, and there's nothing that tried to fix the intersections on that side. So now if we mirror our muscles, you see that we get intersections on these central muscles on the right side. So here's a little trick to mirror the changes from the left side to the right. I have it in the subnet. Now, first things first, there's an important concept to understand in Houdini, especially if you're doing CFX work. This is quite important and handy. If you use something like a split node or any type, if you're blasting and merging things, you're going to be changing your point order. All right. So let's say I've split this and now I merge it back together. Okay. This has changed the point order, meaning that I can't blend the original mesh with the new mesh without it exploding. But there is a workaround for this. If you use this enumerate node, set the type to points. You can specify any name you want for the attribute. This will then store your original point order, which you can use later on. So now if I do this, so I have this rich ID specified, and for my blend shape and the point ID attribute, I actually use that attribute. Now you see it doesn't get scramble the positions. It scrambles the colors but not the positions. And if I only want to change the P, it won't scramble the colors either. So that's very handy, especially if you do. I'm going to use Shift R to change the order of the inputs. Now it's saying keep the original geometry, only change the P attribute from whatever I've changed here. So that's one way of using it. And the other way is if you use an attribute copy. Here's my original mesh. Here's my changed mesh. And if I say P, we'll scramble it. But if I tell it to match by attribute and I specify my orig ID, then it doesn't scramble it. Let's just peek this to show that it is actually making a difference. See, it is updating the points correctly. So this is very, very useful to have. Very useful to have in your arsenal, in your toolkit for CFX work. So I'll just keep this off to the side. But I have used this attribute copy of with this orig ID to my advantage here. Okay. So back to what we're trying to achieve here, we no longer have these central muscles being symmetric because the intersect only affected the left side. So what we're going to do is these are the de-intersected ones and these are the original ones. Okay. Now I'm going to take my original mesh. Because their point orders are still consistent, I don't need to use this attribute to match option. I can just copy the P value, so the position value from the de-intersected mesh to the original mesh, but I don't want to affect the actual position. I just want to store that information on the original mesh, and I'm going to call that attribute new P. Now I'm going to delete everything except the central muscles because those are all I care about. Now in a similar way that I did when I was scaling the muscles down, I've extracted the centroid for those muscles. I snap those central points, those centroid points to the YZ plane because they were a little bit offset. If you look here, it's just a slight offset. So that was just fixing that offset. Now I use this group expression to find all the points on the left side. In your case, you might need to change this tolerance value a bit with a slider just to catch all the points you need for your model. And I have gone and deleted the right side. So now I want to actually just create a group for these points on this open edge. And you can do that with a group create. I made a little typo here. I should have put an underscore. But by default, this is on, so I'm turning off the base group. Instead, I've got include by edges on with unshared edges. Right, so now that automatically groups those for you. And now here, I'm taking this new P value that I saved on my original mesh up here, and I'm restoring them. Okay, this is very much kind of the same idea as using the set T pose. In fact, I probably could have done exactly the same thing here and just call this new P, and this basically would have done the same thing as that. Right, but so now this is going to be like using the extract rest option. So now I'm taking whatever is saved in here and setting the position to that. So I'm taking the old position and setting it to the de-intersected position. And now again, I just wanted to snap these central points to the central line. That's why I created that group to begin with. And now I'm mirroring it across. Okay, so now in theory, this is what we want, right? We want a symmetric mesh with the points mirrored on both sides. However, this is not the original point order that we had here. Okay, I can even show point numbers. You see that one is 12, for instance. Now it's 1089. So that's not what we want. We don't want this change in point order. So how do we get around this? Basically, it's similar to what we did here. I mirrored my original geometry in the same way. So now these two have the same point order, just different shapes. And now, because they have the same point order, I can copy that new P from the de-intersected mesh to the original mesh, just with different point orders, but these two match. But again, I'm not actually changing the P value, I'm just storing it on those points. So the attribute copy is used when the point orders match. Attribute transfer you use when the shapes match. So now basically these two, their point orders match. So that's why I use an attribute copy. These two, their point orders don't match, but their shapes match. So now I can use this to use the proximity to transfer the new p-value on all of these points to all of these points. And then I can just restore that new p on these, which is the original point order of this. Okay, 12, 12. Okay, whereas before, 1089. So that is maybe a little bit confusing, but that is how we've transferred it. If this goes over your head, don't worry too much about it. You can still use it, just you might just have to tweak your tolerance here, and you might have to, depending on your model, you might not have to do these snappings. Okay, and now, so we've made the changes to these central meshes, but we want to have it, we want to keep all the muscles together. So now I'm going to use an attribute copy, and I'm going to match by attribute. So you see it gets, if I just copy the p-value from this to this, because it doesn't match, there are different point counts, it gets scrambled. But if I match by the orig ID, then you see it actually just affects those ones. So my spiel at the beginning with this, that is where it is being used. Then I just update the normals and delete this orig ID. So now let's go up. Let's have a look at what happens when it gets mirrored now. And lo and behold, all those other intersections are gone. We just have the ones we had before remaining. So that is excellent. So we can stash that out, just because this can be a bit slow sometimes. And this is the form that I used for the main video series. I had the muscles de-intersected like this, more or less. It might have had slightly different settings, but it's essentially like this. But there were some things that the muscle solidify broke a little bit. Not broke, but some of the shapes got a little bit mangled. Let me show you. So let's look at this muscle, for instance. It will be easier to see an exploded view. And because I'll fix or require us doing a remesh first, I'm going to have a remesh node to show what the problem is. So as you can see, after the remesh, as well as the muscle solidify, there is basically this chunk missing from the muscle. So the way we can fix that, I'll just do an exploded view here. Basically, we're going to peak this muscle, and we will then also delta mush it, and we're going to use the same, I did a copy parameter here and then paste relative references, but because in the delta mush, this only accepts point groups or groups defined with point attributes, like that, we're going to have to promote the muscle ID from a primitive to a point. We can just use first match, but don't delete original. We still want to keep the original. And then we can use that to delta mush only that muscle. So now we've smoothed it so that when it remeshes it, it does a better job of handling that remesh. And then we want to surface deform it back into the original shape. And we have to delete that muscle ID point attribute, because otherwise it gets confused when there's a point and a primitive muscle ID attribute. So we specify the muscle ID node as a piece attribute. So the surface deform node is very similar to a point deform, but it's a very useful node in CFX in general, because you don't need to worry about a radius, and you can specify this piece attributes too, so that if you have the same piece attribute, in this case muscle ID, defined in all three inputs, it can basically just do the deformation matching only those pieces with the same value. And it just gives a better result than the point deform, and I find. So let's just remove the exploded view. Okay. And now we can see looks much better. And now we can muscle mirror and let's test to see if there are any intersections. And there are some now, but that's okay. So I have a little sub-network that I created. I'm not going to go into it. If you're interested in it, you can dive into it. It basically uses VDB lookups. It's a little bit finicky, but you might have some luck with it, depending on the settings here. But this just got rid of those very tiny intersections. But to be honest, this is me being incredibly pedantic. And most of the time, this type of thing really isn't going to make or break your simulation. If I can find a way to fix something procedurally, I will. So I did it for that reason, and I thought I'd share it, but I will say that it's not super stable or reliable or anything like that. So try it, and if it doesn't work for you, then don't worry about it, but maybe you get some cool results. And then this side here is I just use mask by ambient occlusion to get a to create this mask that shows the external muscle surfaces where we're not going to be concerned about any intersections, because I found that with some of the settings on my micro de-intersector, I was getting changes to the shape in some of these concave areas. And so I just used that mask to blend between the intersected ones and the original ones. But in this case, it's not even actually doing anything. But again, maybe you'll find that type of mask useful for something else. So I left that there just for you to look at if you're interested. So I hope that this has helped you to deal with any intersecting muscles and bones, and that it will help you get much more stable and good-looking simulations.